like we said, we do not fail these three, the questions on the three common probability distributions: binomial, normal, and Poisson. Okay, we don't. Here's another one. Remember, for binomial, they'll give you a probability, right? They'll give you a probability. Then they'll ask something about the thing they've given you probability for. Look at this one. We saw it in question 33. They say that whatever probability of a bomb dropping or striking its target is 70%. If 10 bombs are dropped, find mean and variance. So this is related. Okay, they told you the probability, then they're asking about the mean and variance. Remember that they will always ask you for either the probability of something which is related to the one they've given you probability for. They've given you probability for. They'll ask the probability of something related to it, or they'll ask the mean, or they'll ask the variance. These three should all be known. And that is why when we did them, when we listed, you can see here on binomial, we talked about the mean, which is expectation. We talked about the variance, and then we talked about how you get the probability. Here we also talked about the mean, variance, and probability. Okay? And here we are just going to be finding the probabilities here for normal distribution. And there could be some things that I should put for you for this normal distribution, again, that you should put. You should know that if we say find the probability and it is between two things, okay? That your value is between A and B, or Z is between A and B. We can use Z. Z is between A and B, right? Then you should know that this is just going to be the probability of the bigger one, because we only have for less than. Okay, so less than of the bigger one, which is B, then minus probability of Z being less than the smaller one, which is the one at the left, which is A. And this would give us, right? Now, the other thing you must know is that if I have probability of, let's say I'm starting at negative A and ending at positive A. Okay, I'm starting at negative A and ending at then you must know that what you're going to get is here, you are going to get, yes, you are going to get the probability of Z less than the positive A, or probability of Z less than positive A, right? Then you're going to say minus probability of Z less than negative A, right? According to the rule which we have just done up there. It's the bigger one minus the smaller one. But for them, they are all less than. It is no longer greater than. The Z is now less than as well. But you must know that this one here is just 1 minus this one here, okay? So that means this is going to be probability of Z less than A minus, then you say, in brackets, 1 minus the probability of Z less than A again, okay? Because you should know that probability of Z less than negative A is the same as 1 minus probability of Z less than A. So here we'll end up having probability of Z less than A minus 1 plus another probability of Z less than A, which means it will lead us to this final thing, which says that probability from negative A less than Z all the way to A. This is just going to be, if you say probability of Z less than A plus another one, there will be 2. So it will be 2 of probability of Z less than A minus 1. Remember this one. This is the one to remember. And this is the other one to remember. So I can erase all these. This is just something I was showing you. Okay. And we can have it here. And let me just pull it up. You must know this one. Okay. So I'm going to pull it up, and I can even pull it further up. Let me see if I can. Right, like that. So here we have it. Okay, it's 2 probability of Z less than A, then minus 1. Don't ever forget, minus 1. Here it is. Now let's go ahead and let's do some questions. What are we doing? We were doing number 35, right? Is it number 35? No, number 34. Okay, yes, number 34. 60% of mice are inoculated, which means they are vaccinated, okay, with the serum, are protected from a certain disease. If 5 mice are inoculated, so here we know that our probability, remember that binomial, yes, we started to put it yesterday. We say that, we say X follows binomial. The moment you see you yourself being given a percentage or the probability that something is inoculated, then they start asking about things that are inoculated, then it's binomial, okay? Binomial, they'll always give you the probability, then ask for some other probability related to it. So it's going to, here we have the number of mice vaccinated. Remember, probability follows N, then P, okay? We say X is binomial, then you put the number of mice, then you're going to put the probability that it is vaccinated. So here we have 5 mice vaccinated total. Then the probability is 60%, which is 0.6. Which means that Q is equal to 1 minus 0.6, and it will be equal to 0.4. Just put it somewhere there. Now we're going to say that, what do we have? They want, find the probability that none is protected from the disease. So now for binomial, they actually want probability that X is equal to 0. Okay, that none is inoculated or protected. Okay, we have been given percentage of inoculation. Now they want probability that none or 0 is protected. So probability of X equal to 0. This is going to be, remember that we should put this. We say, remember, X follows binomial probability, and you have N and P. Then you should also then find Q, which will be which will be 1 minus P, which you have found it. Then now you're going to say, find probability of X being equal to small x, right? This is going to be equal to N, choose small x, then P to the power of that small x, then Q is now to the power of N minus x. So here we have probability of X, choose of X0. So it's going to be N. What do we have? This is our N, and this is our P. So you can say N is equal to 5 and P is equal to 0.6. This is what you can do. So if you wanted first, you can write it like this to say, let's do it. You'd say X follows binomial probability with N and P. And you can say N is equal to 5 and P is equal to 0.6. So you can say X follows binomial with 5, 0.6. You should put that. Then you're going to say Q, which is equal to 1 minus P. Q is equal to 1 minus P, and you can now say Q will be equal to 1 minus 0.6, which is going to be equal to 0.4. And now you have it. Okay? So if you wanted to put it in one long sentence, you'd say Q is equal to 1 minus P, which is equal to 1 minus 0.6, which is equal to 0.4. Now that you have these things, you can now say that probability of X equal to 0, okay, this is going to be, if you want probability of X equal to X is equal to N, choose X, P to the X, Q to the N minus X. So it's still on X, eh? N, choose X, P to the X, Q to the N minus X. So here we can now write below, I don't have space, but you're going to write below here. It's going to be, now you're going to say probability of X equal to 0. This is going to be, what is our N? 5. You can just go where we wrote our N. So it's 5, choose 0. Then P is to the 0. Then Q is to the 5 minus 0. So this is going to be, now we're just punching in the calculator and getting our solution. And we would be done with this one, which we need to put. So it will be 5, choose 0. And what is our P? 0.6. So 0.6 to the power of 0. Multiplying Q, which is 0.4, and 0.4 to the power of 5. Then now we can just put our solution. And of course, if you punch in your calculator, you'd be saying 5. Then for choose, you say second function 5, okay? 0. So 5 choose 0, I get 1. I say times. I know that any number to the power of 0 is also 1. So this is also 1. So I'll just multiply by this last one. I open bracket, I say 0.4, close. I say to the power of, which is y to the x. I press the button which says y to the x. It means the power of. Then 5. Say equals. Here I'll get 0.01024. Okay. So the answer I'm getting is 0.01